Hello, ladies and gentlemen. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conklin, New York, and my email address is rbryce@svsavers.org here at work. We are starting Unit 5, Lesson 1, the pages 1 through 4. If you don't understand what I'm saying, you can always scan that QR code and listen to the person who made the worksheets in the first place. So what we're going to start Unit 5 is with sequences and series. This is Common Core Algebra 2. I am doing the non-regent section, so that means you have a final exam, not a regents exam at the end of the year. In Common Core Algebra 1, you studied sequences, which are an ordered list of numbers. Sequences are extremely important in mathematics, both theoretical and applied. A sequence is formally defined as a function that has its domain as a set of positive integers. For example, 1, 2, 3, and so on until the last number, which we're calling n in this situation. A sequence is defined by the equation a of n equals 2n minus 1. So this is a specific sequence. There's the equation. It's a function. Find the first three terms of the sequence. Remember to notate them as a sub 1 equals 2 times 1 minus 1, which is 1. A sub 2 equals 2 times what? I'm going to plug in that 2 minus 1, which is 4 minus 1, which is 3. Now, a sub 3, or a of 3, is 2 times what? Everywhere I see an n, I'm going to put a 3, then minus 1. 6 minus 1, a sub 3 is 5. I'm writing the 3 lower than the a. It's a subscript. Which term has a value of 53? The value means, what's the answer? The answer is going to be 53. So instead of writing a sub n, or a of n, sorry, a of n is 53. So I'm going to put 53 is the same as 2n minus 1. So we add 1 to both sides. 54 is 2n, divide by 2, and we get 27 equals n. That is not the answer to the question. That's not the answer. The question says which term. So let me see. N is 27, so it's the 27th term. A sub 27. That is the answer. There are two ways to do question C. I'm going to do the straightforward answer. Explain why there's not going to be a term with a value of 70. I don't know. 70 equals 2 times n minus 1. We add 1. We add 1. 69 equals 2n. When we divide both sides by 2, looks like that we get 34.5. n equals 34.5. Well, that seems fine. Why can't we have an a sub 34.5? Because the definition says it has to be a positive integer. That's a rational number. 34.5 is rational. And it must be a counting number, also known as a positive integer. So that's why we can't have an answer value of 70. Next question. Recall the sequences can also be described as recursive definitions. Ow, that hurts. Okay, it doesn't hurt that bad. When a sequence is defined recursively, terms are found by operations on the previous term. See, that's why I said this hurts, because you can't just jump to the 53rd term. You have to keep on going with the formula 53 times. A sequence is defined by the recursive formula f of n, my answer, equals previous answer plus 5. So that's what we're doing to it. With the first number, you always have to say what the first number is. The first number is -2. Generate the first 5 terms of this sequence. Well, I wonder what the first number is. F of 1 is 2, -2, sorry. There we go. That's easy enough. For the first one, well, then what is the second number? The second number, again, is the previous number, -2, and the rule is to add 5. So that's 3. Then we take the 3, and we add 5, and we get 8. Then we take the 8, and we add 5, and we get 13. Let me see, 1, 2, 3, 4. So this is f of 3, f of 4, and it says find the first 5. So f of 5, we don't plug 5 into the equation, unlike the other one. We don't plug 5 into the equation. We take 13, take the previous answer, and add 5 into it, and we get 18. Determine the value of the 20th term. Ooh, wow. Hint, think about how many times you've added 5 to -2. Okay, let me see. I added it once, twice, 3 times, 4 times. I've added it only 4 times to find f of 5. So, since I added 4 times to get f of 5, I think I'm going to add it 19 times. So 19 times 5 is 95. So I'm going to do -2 plus 95. It is 93. Okay, we just found the direct rule. The important thing here to remember is that you take the previous number for recursive, you take the previous number, you take the previous number and do the rule to it, whatever the rule is. Here it was adding 5. Determine the recursive definition of f of n for the sequence shown below. Be sure to include the starting value. Well, the starting value is very easy to find. So the first number is 5 because that's the starting value. So to determine what kind of recursive definition we're going to give, there's arithmetic and there's geometric. Looking at this one, I know it's geometric from experience. You have a little bit of experience with these. Geometric is going to have the same ratio. That means if we take a sub 2, that's a scribbly 2, and divide it by a sub 1, that has to equal the same thing as the third term divided by the second term. Or another way to say it generically is the nth term divided by the one just before it. So let's see what 10 divided by 5 is. That's 2. And that has to equal 20 divided by 10, which is 2. And let's check another one, like 160 divided by 80. That's 2. Okay, so this is the ratio. That's the constant. And we're going this way. So that means that the first term is 5, and any term after that, the nth term, is the previous term times 2. Determine recursive definition. There's the definition. For recursively defined sequence, my number is the previous number squared plus 2. And the first number is 2. What is the fourth number? Okay, the first number is 2, and then the second number is the previous number squared plus 2, which is 6. And then the third number is the previous number, which is 6, squared plus 2, which is 38. And then the fourth number is 38 squared plus 2. Yes, I had to get out my calculator for that one. It is choice 4. If I would have looked at the choices, I would have known that it was only possible to be choice 4. However, you always check the arithmetic on your calculator. On the next page, one of the most well-known sequences is the Fibonacci sequence, which is defined recursively using two previous terms. So Fibonacci, you notice that we always need to know what the first term is, but with Fibonacci, you have to know what the first and the second term is, because the rule for Fibonacci sequence is add the previous two numbers. So if we only were given the first number, we wouldn't have the other number to add to it. Generate the values for the third number, fourth number, fifth number, and sixth number. So the first number is 1 and the second number is 1. We add those two together and we get 2. Now we add those two together and we get 3. We add 2 and 3 together and we get 5. 1, 2, 3, 4, 5. And now we add these two together and we get 8. In other words, find the next four terms in the sequence. There we go. We have the terms. On a sideline, the Fibonacci sequence is very interesting because it occurs in nature. Why don't you take a moment right now and Google the Fibonacci sequence in nature. And write down an example right here. And I will grade that. It's often possible to find algebraic formulas for simple sequences and skills that should be practiced. So we're going to find the formulas for these. Recall the domain you mapped set from 1, 2, 3, 4, 5, 6, 7, all up to n. Okay, so here, what does it look like it's going? It looks like that f of 1 or a sub 1 equals 4, because that's the first number. Then, what's the rule? We're adding 1. So a sub n equals the previous number, a sub n minus 1 plus 1. Another way to write that, the number that I'm looking for is a sub n plus 1. Okay, so you're going to see me going back and forth between these two rules. And it's the same thing. My number is the previous number or the next number. This is the next number is my number plus 1. This is my number is the previous number plus 1. What's happening here? We go to 2 to 4, then 4 to 8, and 8 to 16. Looks like the rule is times 2. So the first number, a sub 1, is 2. Any number is the previous number times 2. This one's trickier. The first number is 5 over n over 1. What? Really? Yes, it is. Because that's the second number, that's the third number, that's the fourth number. So that takes some real thinking to do. 5 over 1 is just 5. They simplified it for you. Oh, shame on them. So then that's actually the rule right there. What's happening here? It's negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. Okay, so it looks like it's negative 1 to the nth. A sub n. So the first number is negative 1. Why? Because when n is even, it's going to be positive. A negative times a negative is a positive. And when n is odd, it's going to be a negative. Even exponent, it is positive. Odd exponent, it's negative. This is called an alternating sequence. On, off, on, off, on, off. 10 to 15, 15 to 20, 20 to 25. First, it might look like you're multiplying, but then you realize, oh, nope. The first number is 10, and my number is the previous number plus 5. What do we notice about 4, 9, 16? They are, they're not all even. They're not multiples of anything. Oh, they're all squares. And what is 1 squared? 1. So the first number is 1. My number is 1 over n squared. That's the second term, it's 2 squared. That's the third term, it's 3 squared. That's the fourth term, it is 4 squared. Which of the following could represent a graph of the sequence a sub n equals 2n plus 1? Explain your choice. The huge clue is that we can only use x equaling 1, sorry, that's a 0. We can only use x equaling 1, 2, 3, 4, 5, 6. Remember, counting numbers, positive whole numbers. 0 is not positive. That one's out because that's a 0. That one's out because we have all these fractions. This one's out because it has all those fractions. Only counting numbers for the n-axis. What do you mean the n-axis? Well, that's what they labeled as the n-axis. The answer is choice 3. That's it for the beginning of the unit. The next section, we're going to be going more into arithmetic and geometric sequences and series. So you know what your homework is. It's the next 2 pages. If you have any questions, make sure you ask me in class. See you later.